Hello, game theorists. Today we are in Chapter 3, learning about sequential games. We defined sequential games earlier. Those are games where the players take turns. Games like, you guessed my example, chess. So the way we analyze sequential games is what's called a game tree. And we're going to take this analogy pretty far. So I'll set up an example game tree here. So we'll have two players, player 1 and player 2. So this is where the game begins, where player 1 makes the first move. So we call this the root of the tree, or the initial node. And this is saying that player 1 on their first turn can play either A or B. Oh, notation. I often use P1 for player 1. Similarly, P2 is player 2, and sometimes you have a third player. P3 can be player 3, etc. So to keep this analogy going with trees, we call these two options here branches. So after player 1 makes their move, then player 2 gets to have a turn. So put player 2 down here. So write P2 next to this dot here indicated that it's player 2's turn. And player 2 can play either X or Y or Z. These are some more branches. Now what we call these dots here, these black dots are called nodes. So you can see why I call this one over here, because we call it the initial node. It's just like these nodes down here, but it's the very start of the game, so that's why I put initial in front of it. So maybe after player 2 makes a move, then it could be a case that player 1 might move again. Maybe if they play X. In this case, maybe player 1 can move again in this game. And player 1 can play either M or N. But if they go anywhere else, the game just ends. So we call these over here the terminal nodes. So it's a node where the game ends. And these are also terminal nodes. And then we have to list the payoffs. So I'll put them in brackets here. Or the payoffs are the outcome of the game, how much utility the players get from the outcome. So very important, you always have to specify in the payoffs which player's payoff comes first. So if I write 3.5, 2.5 over here, I gotta tell you which players have 3.5, which players have 2.5. So we'll put player 1 on top. It seems like a logical ordering. So I'll write down here, payoffs are P1, P2. So in this example, the players are named rather unimaginatively. It just made sense that the players will be P1 on top, P2 in the bottom. But if you have we have people's names in there, then it's not quite so obvious whose payoff will come on top. So you guys spell it out. So always write out whose payoff comes first. Let's say we have a 10-0 here, and 1-14, and 7-1, 5-3, 1-7, and 6-2. So that's how you draw a game tree. So player 1 can pick either A or B. After that, player 2 can pick X, Y, or Z. If they play X after A, then the game goes on. Otherwise, the game ends. That's what we have shown here. All right, so we said a game has 3 elements, has players and strategies and payoffs. Now the branches here on their own do not constitute a strategy. So let's get a bit more formal about our definition of what a strategy is. So a strategy is what your book calls a complete plan of action. And here's what they mean by that. It says what you do at any one of your nodes. So the nodes are the points in that game tree where you have to make a decision. So player 2 has 2 nodes here. So you say what I'm going to do if I'm at this node, and also what I'll do at that node. Similarly, player 1 also has 2 nodes. Players say what they'll do if they're here, and also what they'll do if they are there. So we'll list out all of player 2's possible strategies. So they could play X if they're here, and also plan on playing X if they're there. So I'll write that out as X if A, X if B. They can also play X if A and then Y if B. X if A, Z if B. I think I mentioned this earlier, but I'd like to ask you guys some questions in class. It's hard to really replicate that in an online class, but here's my closest attempt. So, how many strategies do you think player 2 has in total? So, go ahead and pause the video here and think about that, how many strategies player 2 has, and when you think you have an answer, press play and we'll see if you're right. Alright, I'll assume you have thought about it for some time. The answer is player 2 has a total of 9 strategies. So you can do these 3 over here, but you can also do y if A and x if B, y if A, y if B, y if A, z if B, and you have 3 more. Z if A, X if B, Z if A, Y if B, I'll just write over here, Z if A, Z if B. So here's a tip to make sure you don't miss anything. I always try to make sure I'm going through this systematically. So here I kept the first one the same, x if A, x if A, x if A. I just rotated through all the options for if B. Once I did that, I went to y if A and I rotate through again. Z if A, rotate through again. That way I'm sure I'm going to exhaust all the possibilities and not make any oversights. So always have some kind of strategy like that when you're writing out strategies so you don't make any oversights. For notation, just make sure it's clear for how you write out the strategies. So you just write, if you've written like say XY for this one, which I don't recommend, that's not clear because I'm not sure is that X if A or is that X if B? Is that Y if A or is that Y if B? So don't do that. It's not clear. This is clear, unambiguous, so that'd be the right way to show the strategies. All right, that's player 2's strategies. Let's move on and look at player 1's strategies. So you gotta specify what player 1 would do at every one of their nodes. So that's what our definition tells us. All right, so player 1 has 2 nodes. They move over here, and they also make a move over there. So let's write that out. Same idea of we want to go through it systematically to make sure you exhaust all the possibilities. So there is A, and then M if AX. There's A, and there's also N, the other possibility, if AX. Keep rotating through, there's also B, and then M if AX, B, N if AX. So now I've exhausted all the possibilities. So player 1 has 4 strategies. So if we're in a face-to-face class, somebody would have surely raised their hand right around here and asked about these last 2. So we only play M or N if AX happens, right? But we play B on the first move, we've guaranteed that we're not going to be here. So is that a mistake? The answer is no, that is not a mistake. The definition of a strategy is that it says what you do at any one of your nodes. So this is one of our nodes, so I still have to say what I would do if I got there. Now that, although I just put into the definition, usually does not entirely clear up the confusion, so here's perhaps a better way of thinking about it that makes intuitive sense. There's always a small risk that a player makes a mistake. So maybe player 1 goes into this game thinking, I'm going to play B, I'm going to play B, I'm going to play B, and then they play A by mistake. So you play A by mistake, and then player 2 responds by playing X, then you find yourself at this node that you did not expect to be at. So you still got to have a plan for what you're going to do if you get there if you make a mistake. So that's why you still specify what you do at the node if AX, even if you're not playing A on move 1. Speaking of mistakes, let me go fix that handwriting. So just keep it in mind, we'll come to this quite a bit. You gotta say what you do at every single one of your nodes. No exceptions. Alright, that's how we set up sequential games. Be sure to tune in for our next episode, in which we find out how do we solve sequential games.